All right, today we are diving into a small but seriously mighty piece of tech that has powered just about everything you can imagine, from little robots in a garage to projects in high-tech labs. We're talking about the Arduino Uno.
So what is this thing really? Well, at its heart, the Arduino Uno is a small computer that you can program to sense and control objects out there in the physical world. It's basically a bridge between your digital ideas and real-world actions.
So what can you actually build with something like this? Honestly, just about anything. We're talking custom robots, smart home gadgets, interactive art, even scientific equipment. This little board is a total launchpad for creativity. The Arduino Uno is a microcontroller board. Now, what's a microcontroller? Well, it's not like your laptop, which has to do a million different things at once. Instead, it's a super compact, dedicated computer on a single chip that's designed to do one specific job and do it over and over again. To really get how this thing works, we've got to know what we're looking at. So let's take a quick tour of the key components you'll find right on the Arduino Uno board. First up is the part you'll probably recognize instantly, the USB port. This is your main gateway to the Arduino. And you know what? It actually pulls double duty. So this one port does two super critical things. First, it gives the board power, bringing the whole thing to life. And second, it's the data highway you use to upload your code, which are called sketches in the Arduino world, from your computer right to the board's brain. But what if you want your project to run all on its own, without being tethered to a computer? Well, that's where this little guy, the DC power jack, comes into play. This jack lets you power your Arduino with a battery pack or just a regular wall adapter. It's what makes your creations truly portable and independent, whether you're building a robot that roams around the house or a weather station for your backyard. Okay, now let's look at these rows of sockets running along the edges of the board. These are called GPIO pins, which stands for General Purpose Input Output. The ones highlighted here are the digital pins, and they're numbered 0 all the way to 13. Think of these pins as the Arduino's senses and its voice. You can set them up as inputs to read a signal, like, hey, is this button being pressed? Or you can use them as outputs to send a signal, like, turn on this light. They are the absolute workhorses for interacting with other electronics. All right, we've looked at the external connections. Now let's zoom in from the outside of the board to its very core, the chip that does all the thinking. So, say hello to the ATmega 328P. This long black chip with all the little legs, that's the brain of the whole operation. It's the actual microcontroller where your programs are stored and where all the magic happens.
So what's this brain actually packing? Well, it's got an 8-bit processor that runs at 16 megahertz. The 32 kilobytes of flash memory is where your code lives permanently, and the 2 kilobytes of SRAM is its short-term memory. Now, I know what you're thinking. Those numbers sound tiny compared to your laptop, but for a dedicated controller that's just doing one job, it's surprisingly capable.
Of course, a sensitive brain like this needs some protection, right? Well, that's the job of this much smaller but critically important component, the voltage regulator. You can think of the voltage regulator as a personal bodyguard for that main chip. It takes whatever voltage you're feeding the board from the power jack, cleans it up, and provides a nice, steady, safe amount of power. Basically, it stops the brain from getting fried. Okay, so we've got power and we've got a brain. Let's get back to those pins and talk a little more about how they actually connect that digital brain to our physical world. So the board has two main types of these GPIO pins. The digital pins we talked about are binary. They only get on or off, perfect for something simple like a switch. But the analog pins can read a whole range of values. This is super important for sensors that measure things that change gradually, like the temperature in a room or how bright it is. Let's put this into practice with a super simple circuit. Making an LED blink is pretty much the hello world of electronics. All you do is connect the long leg of an LED to digital pin 13, connect the short leg to a ground pin, and then upload a simple blink program. And just like that, you've used code to make something happen in the real world. Now, making that LED blink required instructions. So how do we actually talk to the Arduino and tell it what we want it to do? Well, that's where the software comes in. And this gets to the absolute core philosophy of Arduino. It's all built on the idea of being open source. That means the hardware designs, the software, it's all freely available for anyone to look at, to modify, and to share. This community-driven approach is a massive reason for its incredible popularity. To write and upload all your code, you use a free piece of software called the Arduino IDE, or Integrated Development Environment. And one of the best parts is that it's cross-platform. So it doesn't matter if you're on a Windows PC, a Mac, or a Linux machine, it just works. The programming language itself is basically a simplified version of C++, which makes it way less intimidating for beginners to pick up. But don't let that simplicity fool you. It can be expanded with all kinds of powerful code libraries, making it flexible enough for both your very first blanking light and a super complex robotics project. So let's just recap why the Arduino has become such a huge deal. For one, it's inexpensive. You can get started for way less than 50 bucks. It works on any computer, its open source nature gives you total freedom, and it has this perfect balance. It's simple enough for a beginner, but powerful enough for an expert. Ultimately, the Arduino Uno isn't just a piece of hardware. It's a blank canvas for your ideas. It's really an invitation to experiment, to learn, and to build something that has never existed before. So the only real question left is, what will you create?
Let's study more and like, share, and subscribe for such more content. And comment something you want to learn.